Hey everyone, and welcome. Today we're diving into something huge, something that's quietly reshaping the world all around us, the Internet of Things. Now, it sounds super complex, I know, but at its heart, it's a really powerful and actually pretty simple idea. So let's just start with this one big question. What if our physical world, our cities, our homes, our farms, what if it all had a nervous system? A system that could feel and communicate and even react to what's happening all in real time.
And look, this isn't some far-out sci-fi concept. We are literally building this global nervous system right now. And its name? The Internet of Things.
So, what is it really? Simply put, the IoT is this gigantic network of everyday objects. I'm talking everything from tiny sensors to massive machines, all connected to the internet and all of them constantly collecting and sharing data. They're basically the digital eyes, ears, and hands of our world.
And you might think this is awesome, far-off future tech, but no way. It's already woven right into our lives. That smartwatch on your wrist tracking your run? That's IoT. A factory where the machines can actually predict when they'll need repairs? That's IoT. Cars that can talk to each other to help avoid accidents, or even just your smart thermostat at home that learns your schedule. This is all the Internet of Things, right here, right now.
All right, so how does this whole digital nervous system actually work? Well, think about it. Any nervous system needs, well, nerves, right? In the world of IoT, those nerves are what we call sensor networks, and they are the absolute foundation for everything else.
You've got these sensor networks, which are basically billions, and I mean billions, of digital nerve endings scattered all over the globe. They're measuring everything: temperature, motion, light, pressure, you name it. But just having them out there isn't enough. How they're all connected to each other, their topology, is absolutely crucial for how the whole system works.
And this slide right here, it breaks down the two main ways this works perfectly. Over on the left, you've got a star network. It's simple. Every device reports directly to one central hub, kind of like how all your smart gadgets at home talk to your single Wi-Fi router. It works, it's efficient, but there's a huge catch. If that central hub goes down, the entire network is toast. It just goes blind. Now look at the right, a mesh network. This is different. Here, the devices can all talk to each other, passing messages along the chain. This is so important for something like a city's smart traffic grid. If one sensor's path is blocked, no big deal. The data just finds another route. It's really the difference between a simple knee-jerk reflex and the incredibly complex, interconnected web of our own brain.
Okay, but as you can imagine, building a nervous system for the entire planet, that's not exactly easy. The engineers and architects behind the IoT are wrestling with three fundamental challenges that really determine if this whole thing can actually work on a global scale.
So, challenge number one, it's the most fundamental question you can ask. Can you even get a signal? How do you make sure every single one of those little nerve endings can actually report back with the data it's gathering?
And that's what we call coverage. It's all about making sure there's a strong, reliable connection to every single device, no matter where it is. I mean, it's one thing to connect a smart thermostat in a city that's blanketed in Wi-Fi, right? But it is a completely different ballgame to connect a soil moisture sensor that's sitting in the middle of a 1,000-acre farm. The signal has to be there.
All right, on to the second big challenge. Our world doesn't just sit still, right? Things move. So what happens when the nerve endings of our network are constantly on the go? And this is where mobility comes in. This is all about the network's ability to keep a perfect, unbroken connection with the device that's in motion, sometimes at really high speeds. Just think about a delivery drone or a self-driving car. That connection cannot drop for even a millisecond as it zips from one cell tower to the next. Getting that handoff to be absolutely seamless, that is a massive, massive technical challenge.
And that brings us to the third, and maybe the trickiest puzzle of all. You have millions of devices made by thousands of different companies, all running on totally different software. So how in the world do you get them all to talk to each other?
This is the whole game of interoperability. You can basically think of it as the mission to create a universal translator for machines. Without it, you just have a bunch of separate, isolated systems that can't cooperate. But with it, a sensor made by one company can trigger an action in a device made by a totally different company. And that is how you create a truly intelligent, truly collaborative network.
Okay, so as engineers are chipping away at these big problems, something really cool starts to happen. This global nervous system isn't just getting bigger, it's getting smarter. It's evolving, thanks to some amazing new technologies that are plugging right into the IoT.
First up, you've got UAVs, Unmanned Aerial Vehicles. You know them as drones. Think of these as mobile, flying sensor platforms. They can go where fixed sensors just can't, giving us a bird's-eye view for things like monitoring crops or responding to a natural disaster. They're basically the dynamic, roving eyes of the network.
And then you have machine-to-machine communication, or M2M. And honestly, this is where it gets really mind-blowing. This is the point where the nervous system starts to develop its own reflexes. M2M means devices don't just send data back to us. They can talk directly to each other and make decisions, all without a human in the loop. A traffic sensor could literally tell a traffic light to change just to ease up some congestion, all on its own.
So okay, let's zoom back out. When you take all of this, the sensors, the different networks, all this new tech, and you put it all together, you start to see the shape of a truly connected reality taking form. And this isn't just about cool tech for its own sake. It has huge implications for every single one of us.
So why does any of this matter to you and me? Well, this digital nervous system, it's the key to creating smarter cities that can manage energy and traffic way better. It's what allows our industries to become incredibly efficient and so much less wasteful. It's what promises a future with responsive healthcare, where doctors can monitor patients from the comfort of their own home. At the end of the day, it's about building a world that is more responsive, more efficient, and just more connected to what we actually need.
And that really leaves us with one last big thought. We are just at the very, very beginning of this story. We're still just laying down the basic nerves and pathways. And so as this global nervous system keeps growing, getting more complex and more intelligent every single day, the real question is, what will it dream of next?